So the duration of a bond is just the present value of its weighted cash flows divided by its price. So first we need to find all the weighted cash flows. Well, what is a weighted cash flow? It's just the cash flow times the year in which it occurs. So let's look at a table. And this is given in the question. It breaks down the cash flows of this bond. Basically, it's a 5-year bond with $120 annual coupon payments. So we get $120 in each year, and in the 5th year we get the 120 coupon plus the $1,000 par value. So again, the weighted cash flow, we're just going to multiply the year times the cash flow, and then we're going to add it to this column right here. So that's what we're going to do. The first one is just year 1, so it's 1 times the cash flow of 120, that gives us 120. This weighted cash flow is the same as the original cash flow because it occurs in year 1. The second one is year 2 times the 120, and that gives us the 240. So that's the weighted cash flow in year 2. We just weight it by the year, which just means multiplying it. The third one is year 3 times the 120, that gives us a weighted cash flow of 360. And then going on down, it's 480. And finally, we have year 5 times the 1120. Again, that's the par value plus the coupon payment, and that gives us a weighted cash flow of 5,600. So now we have all of our weighted cash flows, and we need to find the present value of them because that's part of the equation for finding the duration of a bond. We need to find the sum of the present value of all of these weighted cash flows. So let's start with this first weighted cash flow, the 120. Well, it occurs in year 1, and the interest rate to use as the discount rate is given in the question as 9%. So we just need to discount that weighted cash flow back 1 year, again, because it occurs in year 1. So we're just going to divide it by 1 plus the interest rate, by 1.09. So when we take the 120 and divide it by the 1.09, it gives us a present value of 110.09. So that's the present value of the first weighted cash flow. The second weighted cash flow is 240. It occurs in year 2. So we divide it by 1 plus the interest rate raised to the second power. And that discounts that 240 back 2 periods at 9%, which gives us a present value of $202. The third weighted cash flow is 360. That occurs in year 3, so we divide it by 1 plus the interest rate raised to the third power. That gives us a present value of $277.99. The fourth one is the 480. We bring that back 4 periods, so we divide it by 1 plus the interest rate raised to the fourth power. That gives us a present value of $340.04. And finally, our fifth weighted cash flow is the $5,600, which occurs in year 5. So we divide that by 1 plus the interest rate raised to the fifth power. That gives us a present value of $3,639.62. So now we need to add up all of these present values. So we just add up this column, and we get a total. The sum of all the present value of all of the weighted cash flows is $4,569.74. And this is the numerator in the equation for the duration of a bond. The denominator is the actual price of the bond, the original price based on its coupon payments and its par value. So now we have to find the price of that bond. We can use our time value of money functions on our calculator to do this. So there are 5 years till maturity, so we enter in 5 for n. The annual yield to maturity is 9%. We enter that in for the interest rate. The annual payment is $120, and the par value is $1,000. So we find that the price, the present value of all of those cash flows, is $1,116.69. So the duration is just the ratio of these two things. The sum of the weighted cash flows, present value on top, divided by the price of the bond. So the $4,569.74 divided by the $1,116.69 gives us a duration of 4.09 years. Now notice this answer for duration is in years because the payments that were part of our bond were in years. If our payments had been in 6-month periods, the answer we would have gotten for duration would have been in 6-month periods. So if we wanted to get that into years, we would have had to divide it by 2.